Pobrecita. Okay,
26.
Okay, so we are recording. Yes, good afternoon. Good
Okay,
afternoon.
we're going to start on chapter 4, section 4. I think that it was 4.5.
Yeah,
right?
good afternoon, folks. So we're going to start with rational equations and expressions. Chapter 4 of the XYZ textbook. And depending on your professor, I don't know which board they're using. The camera will start adjusting itself, so just bear with us, because it will start kind of adjusting kind of weird. But anyway, well, you'll get it. We'll get it.
Okay. In order to add the fractions, right? Since they have different denominators, we need to find the LCD, right? The denominators are different, so we need to find a common denominator. In order to find a common denominator, what we do is we need to factor each denominator. So we start by factoring. First one is 2p plus 12. So the greatest common factor here is a 2. So we factor 2, open parenthesis, and we are left with a p plus 6. The second one, we have p squared minus 36. So how do we factor? In this case, we have the difference of a square. We remember how to factor difference of a square? Right, so the difference of a square, remember? A squared minus b squared, we factor as a plus b, a minus b. So in this case, we have in p 36, 6 and 6, 1 positive and 1 negative. Once we factor the denominators, the LCD is the multiple of those prime factors. So we get one of those denominators, all the factors from the first item. So the LCD will have all the factors from the first one, a 2, a p plus 6, times any other factor from the second denominator that we haven't used. So in this case, we need also a p minus 6. So this is the denominator that we need. So that way we can add the two fractions. So we need a 2, p plus 6, and p minus 6. So now we compare. We have the 2, the p plus 6. We're missing this item. The item that we're missing is the one that we have to multiply by p minus 6, top and bottom. So we have now the first fraction will be p plus 7 times p minus 6. And the second fraction, the LCD that we're looking is 2, p plus 6, p minus 6. So we are missing, in this case, we have these 2. We are missing 2. So that's the one that we need to multiply numerator and denominator by. So now we have 6 times 2 is 12. Now that they have the same, copy the denominator once and work on the top. FOIL, etc. P times p squared minus 6p plus 7p, 6 times 7, 2, plus 12. Add this, so we have p squared plus 1p plus 1p. Negative 42 added to 12, that would be 30. Negative 30. over 2p plus 6, p minus 6. Now factor the numerator. How do we factor the numerator? How do we factor this? Find the numbers that multiply give us 30, right? Negative 30, with two numbers opposite sign. But when we add it, we get a positive 1. So that will be what? Two numbers that multiply give us negative 30, but when we add it, we come up with a positive 1. 6 and 5. Which one is the positive? Which one is the negative?
6 net a positive.
Exactly. 6 is the positive, 5 is the negative. The denominator is p plus 6, p minus 6, and now we simplify what is in common. In this case, these are the same. So when we divide, this becomes 1. So we are left with p minus 5 on the top, and the bottom is 2 times p minus 6. That's 26.
Should I do 29? Okay. I'm going to read this portion here.
I took the whole piece. I know.
Yeah, so this will be easier because I'm a left, he's a left too. Yeah.
Yeah, the bigger, the more I.
So since I'm going to look at the camera, let me know if I'm going out of the.
Yeah, no.
So let's go ahead and try number 29. Very similar to number 26, but I want to hit something negative. Because it's negative, right? So we have 2n minus 2 over n squared plus 4n plus 3 minus square 5n plus 6, and that would be n minus 1. Okay, so we have one plot. This is how we're subtracting. Again, in order to find the least common denominator, we must factor each denominator. So this is equals to. I mean, I'm not going to factor this one yet, so I don't know what's going on. Let's just leave it to n minus 2 for now. Factors of positive 3, that gives me positive 4. There are not that many combos, simply 3 times 1 and 3 plus 1, right? So n plus 3 times n plus 1, okay, minus 1. Once again, factors of positive 6, that gives me positive 5, 3 and 2, right? 3 times 2 equals 6, 3 plus 2 equals 5. So n plus 3, n plus 2. Now we are ready to build the LCD. Of course, I need n plus 3. I need n plus 1. I already accounted for n plus 3. I still also need n plus 2, correct? So we'll have 3 binomials, each denominator. So this is going to be what? My new denominator will be n plus 3 times n plus 1 times n plus 2. I might be outside the screen a little bit. N plus 3, n plus 1, n plus 2. No, I'm still there. There you go. Okay. So now, of course, I have 2n minus 2. Here I have n minus 1. Now, which one I'm missing? Notice that I have n plus 3, n plus 1. I still need n plus 2. Okay, so we'll multiply here n plus 2 times n plus 2. So here, of course, we need to augment the first fraction by multiplying n plus 2. On the second one, we already have n plus 3. We have n plus 2. We're still missing n plus 1. Okay, so we augment by multiplying n plus 1. Of course, to be proper, this is what we're doing. Multiply n plus 1 over. We always augment by 1. Same thing, top and numerator denominator equals 1. Okay, over a equals 1. Almost done. Now it's just very tedious. So with all the respect of my professor, I'm going to raise some work. Okay. So it's going to be kind of painful. Let's go ahead and you don't have to. We'll go to. I think I need to get paper later on. I'm going to be a little bit lazy here. Let's see if we can do a lot of steps at once. So let's FOIL. Let's distribute this n to n times n. That will be 2n squared. 2n times 2, that's 4n. We already have 4. Negative 2 times n minus 2. 4 minus 2, 2n, right? So I'm just going to do here 2n. Negative 2 times 2 minus 4. So we FOIL the O and the I we just did, and we combine like terms. So hopefully folks watching the video. Okay, so now I'm going to leave the minus for now like this. Minus, I'm going to put a big parenthesis. Okay, so let's go ahead and fold this guy. N minus 1 times n plus 1, that's difference to square. So this guy, if we fold, that will give me n squared minus 1. Okay, if we fold, so it will be n squared minus 1 over, this is what the laziness come, over those 3 binomials, right? I'm not going to write it, but I should do it, right? Should I write it for me? Yeah. Just be proper, right? She's writing her notes. N plus 3, n plus 1, n plus 2. Okay? Now we need to distribute the negative. So this is the key. It will be minus n squared plus 1. This is where most of the problems are. We forget to distribute the negative. So that means that we need to change the sign of whatever is inside the parenthesis. So it will be minus n squared plus 1. Okay? So I have 2n squared minus 1n squared. That will be 1n squared. Right? Then I have plus 2n. Now I have negative 4 minus 1 with negative 4 plus 1, which will be negative 3. Okay, good. This one simplifies. Okay, and in theory, we should stop here, but we need to see if we can factor the numerator to see something simplifies. We factor the numerator, sometimes some things simplify, sometimes don't. So we just have to factor to see what's going on. I still have space for another step. So factors of negative 3, that gives me plus 2. Don't have many combinations. 3 times 1, and 3 minus 1 would be 2. Okay? So it would be, the 3, of course, has to be the positive, and the 1 the negative, over n plus 3, n plus 1, n plus 2. And of course, common factor, numerator, denominator, n plus 3 over n plus 3 equals 1. So adios, bye-bye. So the final answer would be n minus 1 over n plus 1 n plus 2, and we are finished. Perfect, we have the whole time. Okay. I was going to do for paper. The person.
Erasing.
No, no erasing it.
Okay, so this will be better.
Still doesn't.
Still?
The network services is here.
Oh,
They're in the classroom.
okay, perfect.
I
Okay.
don't think that you want to see, you can like test it out.
So we'll go there for the next review,
Okay.
which will be, thank you so
Okay,
much,
no
okay? So
I
still,
don't know
right?
why this
Huh?
is
The
erasing, but
markers.
Yeah,
Maybe
might
the
as-
marker?
The markers are expo.
Yeah. No, so
Okay.
anyway, Okay, anyway.
We use a different marker?
So keep going, and then
Okay.
I know what to give me a copy. So I can read this other part. So try this one.
Number, which one we try?
I did number two.
34?
Uh-huh.
34?
Mhm. So now it's multiplication, right? So we did one plus, one minus, and now we're going to,
You want me to multiply that?
Multiply, yeah.
Okay, so number 30 then. Miguel?
Hmm?
30? Okay,
Yeah, multiplication, yeah.
okay.
And then I'll do a division one.
Okay, multiplication is 2 r cubed plus 8 over r to the 5th minus 4r cubed times r to the 6th minus 4r to the 5th plus 4r to the 4th divided by r squared minus 2r plus 4. Okay, so in this case, that's again chapter 4. It was the first sections against for us, right? We need to factor. Now we need to remember how do we factor when we have the two terms. And this was, well, for our class was in chapter 3. So how do we factor binomials? And we have different formulas then, right? It was the difference of squares, right? The difference of squares, and for the difference of square is a plus b, a minus b. We were having also the sum of squares, but the sum of squares did not factor, right? We call it that this was prime, with this one does not factor. And we were having the sum of cubes and also the difference of cubes. Okay? The sum of cubes. Remember the sum of cubes? It was 1a and the square. 1a and exactly. This is the same. Yes, the same as the question, the same. 1a, 1b. For the second term, we have the squares. The a square, the b square, the middle sign is the opposite. So this was the same. This is the opposite sign of the original question. And we multiply. AB. And always plus. Okay?
So,
The slope.
So,
so same opposite always.
Same, same, the same, opposite sign, always plus, always positive.
I remember before the test, I was like, okay, I was remembering, and then, when I put it, I just wrote it down. I wrote it down.
Exactly. And with the minus, the same deal. The same, so that would be a minus, a squared, opposite, always plus. Right, this is a cube plus b cube, 1a plus 1b. A cube minus b cube, and 1a minus 1b. The other ones are the squares. In the middle term, opposite this product. Okay. So now we have here an r cube plus 8. Two pieces, nothing in common. So we go to our repertoire to exactly, we go to other soap. And the one that is matching here is this one. Because at least it gives us the hint of a cube. This 8 is a perfect cube. 8 is 2 times 2 times 2. So our A will be R in our case. And B is 2. So if we use that formula, we have R, 1R plus 1, 2, R squared, 2 squared, which is a 4. This is the same, the opposite, multiply these two to R. So we have R squared minus 2R plus 4. The denominator, there are two pieces, but in this case, they have something in common, right? We have the R cube. We have the R cube. So we are factoring R cube. So we have, because that's the greatest in common, R squared minus 4. This one is still could be factored a little further, right? Because this is still the difference of squares. So that will be the first formula. R minus 2, R plus 2. The numerator is R cubed. I'm sorry. This is here, R cubed. The numerator is R plus 2, R squared minus 2R plus 4. Next fraction. R to the 6th, 4R to the 5th, 4R to the 4th power. The greatest in common, the greatest common factor, the greatest divisor in this case, what would that be?
2 or 4.
R to the 4th, exactly. We factor R to the 4th. When we pull out the R to the 4th, we are left with an R squared minus 4 and 1R plus the 4. Divide by. Now, this trinomial at the bottom, R squared minus 2R plus 4. Could we factor that out? Can we find two numbers that multiply, give us 4? But when we add it, we come up with a 2.
Yes.
The multiply give us 4. But when we add it, we get 2. 4 times 1 will give us 5. 2 times 2 will give us 4. So no. This one, no, it does not factor. Now the one on the top will factor. This one, yes, because that will be two numbers that multiply, give us 4, but added is minus 4. So this one will factor, and that will be R minus 2, R minus 2. Denominator, R squared minus 2R plus 4. Over here is R plus 2, R squared minus 2R plus 4. And now we start simplifying if we see something in common, right? We could simplify now. And R plus 2 could be canceled out with this R plus 2. Divide by, so that gives us 1. This R minus 2 from here, right? With this one. We divide it. R squared minus 2R plus 4 with this R squared minus 2R plus 4. So this one is also gone. And we are left with an R fourth over R cubed. So that means that we could still simplify more. We still have R minus 2. So R to the 4th and R cubed, that will be R, exactly. So this is R. So we are left with 1R and R minus 2. Over here, everything gets simplified, and that will be simplification. So that's a good review of the formulas.
Yeah.
My goodness, that was brutal. Okay. For folks here, I would like to change. I would like to do. We did one adding, subtracting, multiply. Let's do one division. The one that is in the video is just too big. It was ridiculously big. So I'm going to use a different one. I think it's just too much. So I have this one. So I'm going to put it number 38. To divide just too much. So I have 2m squared over m squared minus 8m divided by 8m squared plus 24m over m squared plus m minus 6. The same old, everything is almost the same. One thing that we have to remember, every time we divide, is the same thing as what? No, divide is the same thing multiplied by the reciprocal, right? Division multiplied by the reciprocal. So what I like to do, even in my class, my student will know that I try to factor and flip it at the same time, okay? So let me start with the first rational here. So it'll be 2m squared, that one cannot be factored. Now, if I want to be picky, I can just do for now, I can just do 2 times m times m. That's 2m squared. What do I have in this denominator? M squared minus 8m. This is m times m, 8 times m. So therefore, the common factor will be m. If we quote unquote pull the m out, we leave 1 here minus 8. Okay? Division is the same thing as multiplication of the reciprocal. This is what I'm going to do both at the same time. This denominator becomes our denominator. Let's flip it. This numerator becomes the denominator. Okay? So let me start with this denominator that goes here in the numerator. Factors of negative 6, that gives me plus 1, positive 3, negative 2. Will be m plus 3 times m minus 2. Let me repeat, we're doing 2 steps at one. Not only we are factoring, we're also changing from division to multiplication. And this numerator becomes my denom, 8m squared, 24m. So remember, 8 is the same thing as 8 times 1, 24, 8 times 3. Of course, we have a common factor, 8, right? We have m squared, m times m, 1m, so we also have m as a common factor. So we can factor out 8m, correct? So this was m times m, this is m. So if we factor the 8, the m, so we're stuck with only 1m, plus factor the 8 and the m, I'm stuck with 3. Yeah? I always tell my students, let's go ahead and verify that we factor properly. So we go backwards, 8m times m, that is indeed 8m squared, 8m times 3, 24m. So we factor appropriately. Now that we are factored, we call Mr. Linde to see what we can eliminate, right? So let's see, what can I eliminate here? M plus 3 over m plus 3 equals 1. I have 1 m here with another m. M over m is equal to 1. M over m equals to 1. We can simplify the 8 and the 2, and the 8 and the 2, but let me rewrite it to see what we have. So far we have the 2 parentheses m minus 2, and I have the 8 over m minus 8. Did I leave anything behind? All right. So right, 2, 8. And of course, we know that 2 over 8 is the same thing as 1 over 4. It's a common factor 2. So 2 divided by 2 is 1, 8 divided by 2 is 4. So let me just write that here on the side. So 1 times n minus 2 is simply n minus 2, 4 parentheses m minus 8. And we are finished. I'll be tempted to simplify the 2 and the 4. Can I do that? Yes or no? 2 and the 4. 2. This 2 and this 4. May I simplify it? M minus 1 and then 2 times? 2, no. No, right? No, we can't. Remember, folks, the only thing we can simplify are factors. This 2 is a term. How do I know? Because it's connected with a plus or minus. So this 2 is a term, so the 2 by itself cannot be simplified. We can only simplify factors. Yeah? So, done. So hopefully this was not as bad as the one in the we just wait to watch.
What's number now?
Simplifying complex fractions.
Okay.
Oof, huh?
Which
These
one
ones.
was? Number 34?
I don't know, either 30, 33, yeah, 33 or 34. We should look for something nice.
33 or 34?
Yeah, do one of those and then I
Okay.
look for something less aggressive. Huh?
Give me a good one for this one, right? Okay, 34.
This is the first time I used the word on this side. That's what it is.
Oh.
So you have the layer of.
I don't know.
Mhm.
Okay. Number 34. Let's see. We have 64 plus 1 over d cubed divided by 4 minus 11 over d minus 3 over d squared. Okay. So we have fractions on the numerator and we have fractions in the denominator. What we're going to do is we're going to find a common denominator. Okay, common denominator for all of these. Remember that the common denominator is the multiple of those factors. But the only factor that we have here is really a d. We have a d squared, and a d cubed, right? The denominators are d squared, d cubed, of course, a 1, 2. We want the multiple. So in this case, which one is the multiple? Multiple. That should be the multiple is the one that we find by multiplying. And remember, the multiple is usually the greatest. Even though I say the smallest common multiple, the smallest multiple will be d cubed. We can find d4, d to the 6, d to the 100, but the LCD would be the smallest common multiple. So in this case, we want to look for d cubed. So what we're going to do with this d cubed is that we are going to multiply the numerator and the whole denominator by this quantity, the biggest quantity. Why do we want the biggest quantity? Because the biggest quantity is the multiple, so we could cancel the smallest one. We don't want something small because we will not be able to simplify it. So we want a d cubed.
That's d cubed.
Exactly. This is the one that is telling us. So we want the cube in this case. And the same quantity that we do top, we will do a numerator and denominator. So d cubed and d cubed. So that way we're not really changing the expression. We are dividing, we're multiplying by 1, right? So when we distribute these guys, when we distribute this, what we're really having is a 64 times d cubed. 1 over d cubed times d cubed. In the denominator, we have 4 times d cubed. We have 11d times the d cubed negative 3 over d squared times d cubed. So now we could simplify. So we have d cubed divided by d cubed. So the numerator becomes 64d cubed plus 1 over 4d cubed minus a d cubed divided by 1d would be what?
D squared.
D squared, perfect. And a d cubed divided by the d squared, a d. So now, no more complex fraction. We just have a polynomial on the numerator and one polynomial in the denominator, factor. factor the top. What do we use here? Remember, we just did. How do we factor 64d cubed plus 1?
Difference of cubes.
Yes,
The sum.
the sum of cubes. Can we remember how to do it? We have 2 and 3.
So,
Exactly. So, okay, 64d cubed. So what will that be then?
in an 8. I mean, no.
The cube root of 64 the cube, right? Because now we need to find out the quantity that the multiply by itself. Exactly, 4 times 4 times 4. So we want a 4. So this is 4 in D. 4D times 4D times 4D. So we need a 4D. And on this section, if we have a 4D, this has to be the square. So that will be now 4 times 4, 16. So that will be 16D squared. 1, well, 1, that's easy because 1 is a perfect cube, perfect square, right? So 1 is 1 here. The same, the slope, like you say, opposite, minus, multiply this 2, 4D, always plus 1 squared, 1 times 1, 1. Now, the other piece here, 4D cubed 11D squared minus 3D. How do we factor this trinomial? What is in common to all the three? We could factor 1D, right? 1D. We can factor 1D and have a 4D squared minus 11D minus 3. Now we factor this trinomial. How do we factor this trinomial? So we can do the FOIL method, right? Or we can do the AC method. Right? To know, I don't know which one you were doing, the AC or the trial and error?
The AC.
AC. First times last. 4 times negative 3 is negative 12. Can we find two numbers that multiply, give us negative 12? But when we add them, right? When we have the sum, we have negative 11. So that means that the number has to be one negative and one positive. What are the numbers whose product is negative 12? But
Wait, that will equal 11.
yes.
Yeah.
First, that the product has to be 12.
Negative 12 plus 1.
Exactly. Negative 12 and a positive 1. So now we are going to rewrite this negative 11D as negative 12D and positive 1D. Right? That's what we're doing with the AC method, rewriting that middle term as two pieces. So now we have the last term is a negative 3, the first term is a 4D squared, and we could factor by making two groups. From the first two groups, 4D squared minus 12D, what is the common factor?
4, no?
Exactly, what else?
4D.
40.
4D, open parentheses, and we left with that
B.
D minus 3. From the other two, the common factor is positive 1. They have nothing that in common, so we put D minus 3. Factor again, so this will be one parenthesis will have the 3 minus D. The other parenthesis will be the 4D plus 1. Okay. Let me rewrite this. Right. Okay. Numerator 4d plus 1. 16 minus 4d plus 1, this is not factorable because it's two numbers that multiply give us 16 and other -4 no. So I'm just going to copy 16d squared, 4d plus 1. In the denominator, we have the d, and we also have the d minus 3, the 4d plus 1. And that's it, right? What is in common? In this case, we have the 4d plus 1. So we have 16d squared minus 4d plus 1 divided by a d times a d minus 3. And that would be how we simplify this complex fraction. Okay? One way is look at all the denominators and you need to try to find for the LCM, the smallest common multiple. The multiple is not because it's a list, but it has to be something bigger because the multiple, all the denominators they have to go into exactly.
And that's usually for complex division when it comes to that, right?
Exactly. For complex fractions, we also need to find the LCD when we're solving equations. Adding fractions, then we want to find the LCM, the multiple. Yeah. Every time you have fractions with different denominators, we find the LCD.
Least common denominator, least common multiple.
Least common multiple, yes. Okay, so now we're gonna do.
Should we do another complex fraction?
Yeah.
I'm not going to use the one on the review because it's very similar to this one. It's just too much.
Okay,
So we lose.
want to erase it?
It's going to respond something here. This one. Erase that one. Is that okay?
Okay. Bring it here so that way you have this.
So I have this one. Let's try this other one. It's 5 over y minus 4. I erase it later. Over 3 over y plus 4 plus 2 over y squared minus 16. I'll go there in a few. Okay. So once again, we need to look for the least common denominator, least common multiple. So here I have, it's a complex fraction, it's a fraction made out of fraction, obviously. So I have y minus 4, y plus 4, y squared minus 16. So first we better factor this one to see if we can find the least common. Okay? So I'm going to be a little bit lazy. So I'm going to erase, even students that will be watching the video later on, I'm going to erase the y squared minus 16. I'm going to rewrite as y plus 4, y minus 4. That was lazy. Okay, and then of course, now we need to find the least common denominator. Obviously, we need to have y plus 4, y minus 4. Oh, y plus 2 is already accounted for. Y minus 4 is already accounted for. So my LCD will be indeed plus 4, y minus 4. So what do? We multiply numerator and denominator by the LCD. So I'm going to do the following. Let me see this one. So I'm going to multiply this numerator by y plus 4 over y minus 4. This is over 1. Okay, so we don't get tempted to multiply top and bottom. So I always tell my students, write it over 1. It looks ugly, but put it over 1. It's better to be ugly and correct than beautiful and incorrect. Right? The same thing here. We multiply this puppy by y minus 4 times y plus 4 over 1. Likewise here, y plus 4, y minus 4 goes over 1. If we multiply by the correct LCD, guaranteed the denominators will eliminate. So we'll go from a complex fraction to a simplex fraction. So let's see what we have in my numerator. Y minus 4 equals 1. So my new numerator, I'm not going to distribute yet. It will be 5 times y plus 4. My complex denominator, what do I have? Y plus 4 over y plus 4 equals 1. So I have 3 times y minus 4 plus. And it's easy because y plus 4, adios, y minus 4, bye-bye. So that will be plus 2. Yeah. From this ugly thing to this pretty thing. Okay. So there's not much to do other than breaking the parentheses and see if something simplifies. Most likely nothing will simplify. So let's see what we have. 5 times y, of course, 5y plus 20 over 3 times y, that is 3y. 3 times negative 4, that's negative 12. Plus 2 minus 10. I did 2 steps in one. I didn't do it properly. So it will be 3 times negative 4, that will be negative 12. Plus the 2, that will be minus 10. And we are happy. Of course, I'm tempted to simplify 20 over 10, that would be 2. But no, we cannot do that. Why not? We can only simplify factors, not terms. Right? They are connected by plus or minus, so we don't simplify those. Okay, let's wait a little bit. We should do simplify. It just so happens that in my class today, the first question was simplifying simplifying simple fraction and solving equations, rational equations and radicals. That causes most trouble.
Okay. So what are we doing now? Solving?
I think we should solve the code 2.
37?
And the 37, and then I'll do the 38. Okay. So while you do 37, I'll be right back.
Okay.
Is the next math, it's like algebra 2 with Greek calculus?
Yes. Little algebra too, but no, not
Just
three.
functions.
Functions.
Functions, when they go to logs and
Yes.
high school.
Yep. Number 37. Let's see. Maybe it's left and right. 37. We have solving. So let's see. 3n over n minus 5 minus 2n over n plus 1 equal negative 42 over n squared minus 4n minus 5. So now
I always keep one.
We
I
have-
always keep one with vinegar.
solving fractions, right? Solving equations that have denominators. So again, the same deal. We need to find the LCD, right? We need to find the LCD. How do we find the LCD? How? How do we find it?
We have to factor out the n squared.
Exactly, we had to factor everything. Well, n minus 5 is done already. So I'm just gonna put parentheses here. N plus 1 is also done. And now we're just gonna get n squared minus 4n minus 5, right? Factor this, find two numbers that multiply, give us negative 5. So when we add it, we get negative 4. What do we get? The multiply,
Yeah, so it's gonna be negative 4.
the multiply give us negative 5. Whose product?
5 and 1.
5 and 1, no choice, right? 5 times 1. 5 times 1, opposite sign. So one of those will be positive and one of those will be negative. Which one will be the?
It would be -5 plus 1.
Exactly, -5, +1. And then we have n times n squared. So now that everything is factored, we find the LCM, the multiple of those factors, right? So we need, remember that the LCD, we needed to cancel the stuff. So definitely we need an n minus 5 because if not, how else could I cancel that, right? So we need the n minus 5 in order to eliminate this. In order to cancel the second denominator, right? We need an n plus 1. And we also need any other factor that we haven't used. But we already used both of them. So this is the common denominator. This is the LCD, the LCM. Since this has an equation is whatever we do on the right, we can do it on the left. We could multiply by this amount on both sides, right? So we multiply here. So I have 3n over n minus 5. I have 2n n plus 1, and I have a 42. I'm just copying this again. When we multiply by this n minus 5, n plus 1 on the right side, and also on the left side, right? We don't have to do it top and bottom. We just do it on both sides, right? Just on top, everywhere, since this has an equal sign. We start simplifying. That was the whole point. This n minus 5 is going to cancel and leave us with the 3n times n plus 1. From the second fraction on the left, the n plus 1 will divide with the n plus 1 and leave us with the 2n times n minus 5. On the right-hand side, the n minus 5 simplify with the n minus 5, the n plus 1 simplify with the n plus 1, and then leave us with the negative 42. Now we have an equation without the denominator. Like Professor was saying, the LCD, if we apply the correct LCD, it will divide the other items and will give us something without the denominator that we can handle. We distribute and so forth, right? So now let's finish this. 3n times n, 3n squared, 3n times 1 plus 3n minus what? 2n squared, negative 2n minus 5, positive 10n, combine line terms, 3n squared minus 2n squared will be 1n squared, 3n, 13 exactly. The 42, what do we do?
It'll go the other side, so it'll be a positive.
Positive 42 equals 0. And hopefully we're able to factor. If not, then we use the other techniques, right?
Yeah.
Complete, quadratic, and so forth. But let's see. Can we find two numbers that multiply, give us positive 42? Find two numbers that multiply, give us positive 42. So when we add it, we get 13.
Yeah.
The one that
6 and 7.
6 and 7, right?
Mm.
Check it out. Okay, 6 and 7. So we have n times n, 6 and 7, plus equals 0. So we have these two equations that we could find out, right? n plus 6 equals 0, n plus 7 equals 0, negative 6, negative 7. These are the solutions for this equation, but they might not be the solutions for the original exercise. Why is that case? Because, yes, the denominator. And we know that the denominator is how many pieces we divide it. So the denominator cannot be 0. So the solution cannot be positive 5, because 5 minus 5 will be 0. And the solution cannot be negative 1. Well, it's not one of those. These are the ones that cannot be. The solutions cannot be positive 5. The solution cannot even be negative 1, because those are the restrictions. These are the ones that make the denominator 0. So in this case, we just leave it like that. Of course, if you have time, you get it and you plug it in. Mhm.
One more. Again, this other one, I'm going to take it, not going to use the one from the review. Those are just too long, and I think it's worth going that. It's better to do something smaller or properties. Anyway, so we have 50 over m squared minus 25 plus 6. Okay. Nope. Okay, there you go. Okay. I always like to start. Once we have the problem, we always have to find the exceptions. Oops, and the LCD. Okay. Since of course my value is in the denominator, my denominator cannot be 0. So we always need to avoid what, where? 0 in the denominator. What numbers I must avoid? And can bring anything except
6.
well, the denominator here is 6 over 1.
So,
So my denominator is m plus 5. So when m plus 5 equals 0, m equals negative 5, right? So that means that m cannot be negative 5. Also, something that I should have done first, I'm going to be lazy. So we need to factor this guy, n plus 5, n minus 5. This is the difference squared. So I'm going to be lazy. I'm going to erase this, and I'm going to write n plus 5, n minus 5. My 5 always look funny, so let me just make sure I write the 5 properly. And then okay, so of course we already worked with m plus 5. What happens when m minus 5 equals 0? M will be positive 5. So the two numbers that I must avoid. So my exceptions are m cannot be negative 5, m cannot be 5. What happens if m is either of those two numbers? My denominator becomes 0, and we still don't know how to divide by 0. So that's the first thing that I always like to do, find my exceptions. When you move to college algebra, your professor will talk about the domain. But in here in 1033, we talk about what are the exceptions. Of course, this is 6 over 1, so this is we're safe here. And the second thing I like to find is my LCD or LCM, which will be m plus 5, m minus 5. M plus 5 times, let me just write it here, times m minus 5. Anyways, I need to rewrite anyway. So I have m over n plus 5 equals 50 n plus 5 and minus 5 plus 6. So what do? We proceed. So we multiply by the LCD on the left and on the right. So I multiply this guy by so it's m minus 5 times m plus 5. I always tell my student this is over 1. So you don't get tempted to multiply the top and bottom. So I tell it looks ugly, but again, I always say they look ugly, but correct. So here I multiply by the denominator. So when I distribute, I will have here m plus 5 times m minus 5. And then I'll have plus 6 times m plus 5 minus 5. And it's kind of tight here, but hopefully we know we can follow. And now we can start simplifying. So the ninja. So m plus 5, bye-bye. So on the left-hand side, I have m parentheses m minus 5 equals m plus 5, adios, m minus 5, adios. That will be 50 plus. Now, so take a shortcut. Remember, m plus 5, m minus 5 came because we factor m squared minus 25. M squared minus 25, right? But now this is multiplied by 6, so it will be 6 parentheses m squared minus 25. And let's see what we have. And we need, by the way, much cleaner this equation than this one. They are equivalent, but this one I like much better, right? As long as the m, we don't violate those two rules, everything is safe. Now we just simply have to break the parentheses. M times m, we distribute m squared minus 5m equals 50 plus 6 times m squared, that would be 6m squared. 6 times negative 25 minus 150. Yeah. Well, we ended up with a quadratic equation. As always, tell my student, let's equal it to 0, except one case, but this is not the case. So I prefer my m squared, the lead coefficient, to be positive. So I'm going to move everything to the right. So 1m, 6 minus 1, that would be 5m squared. Then I have negative 5m. When I move it to the right, it will be plus 5m. And then I have 50 minus 150 will be minus 100 equals 0. Let me see if I get it right. Yeah. Okay. I have a greatest common factor, 5 times 20. So I can factor, I can divide by 5. Okay. Divide by 5 on the left, to the right. So of course 0 equals 5 divided by 5, that is 1m squared. 5 divided by 5, that is plus 1m. 100 divided by 5, 20. Okay. Yeah. So now we're back to basics. We need to find factors of negative 20. That gives me positive 1. It will be positive 5 times minus 4. 5 times negative 4, negative 20. 5 minus 4, 1. So m is a plus 5 times m minus 4 equals 0. 0 property factor. So when m plus 5 equals 0, how much is m? Negative 5, right? So m plus 5 equals 0, m equals negative 5, or when m minus 4 equals 0, m equals 4. So we are very happy because we found two solutions. Yay! No, let's not celebrate. We need to look at the exceptions.
Yes.
Notice that even though we believe m equals negative 5 is a viable solution, it is not. So this is one of the exceptions. So thanks, but no thanks. Adios. Go back to parity. So we keep only 1. So we reject 1. We accept 1. M equals 4. Yeah, but this m equals negative 5 was one of the exceptions that we identified at the beginning. In college algebra, you will hear that m equals -5, when -5 is not part of the domain of the function, but we're not going to use the word domain at this point. Okay, okay.
Inequalities?
Continue, let's see, finish, yeah.
Inequalities, that was section, that was
That was,
chapter 2. right?
yeah.
Oh, yeah. we could do-
Something else?
Hmm?
You have something else?
No, I was just, inequalities, writing,
Good.
solving inequalities, huh?
Oh, graphing the inequalities, 52.
Okay.
There's no issue, just for the exceptions, because I remember we covered that
Mhm.
when we did. But like when you found that it was because of those
You,
oh
That
because
is-
it's equal.
the denominator cannot be 0.
Yeah.
It's not allowed to be 0.
Okay.
The numerator could be 0, but the denominator, no. How can we divide by 0? How can you get 5 out of 0? Right? That's not possible.
Yeah.
We could have the other way around. We could have a 0 out of 3. Of course, they give me 3 questions, or they give me 3 attempts to shoot on the basket, and I miss all of them. Then that's possible, 0 out of 3. But the other way, no. This does not exist. This is not a real number. It's not possible. So that's why are those exceptions. Getting the denominator and make it equal to 0. So we restrict us. So that's why he did that at the beginning. He said, okay, I don't know what the solution is, but I want to know which numbers cannot even be a solution, because that will not be possible to start with. So separate it on the beginning, work it out, and then we double check. This was one of the restrictions. I cannot use this value, and then you reject it. Okay. So.
So every time we have a rational, this is what I was saying myself, every time we have a rational, avoid 0 in the denominator. Every time I have a square root, avoid negative in the radical.
Okay, graphing lines and graphing inequalities, right? That's one of the exams, right? To graph an inequality, we graph the line first, right? I remember, at least in class, we used to call it the boundary line. First, graph the equal part, y equal -2/3 x plus 3. And this was the beginning. We did it by making a table, plugging points, rise over run. There was different techniques, right? In this case, this equation is a nice slope intercept form, so we can use that first. You remember? What is the y-intercept in this case? Exactly, 0,3. We begin when x is 0, y happens to be 3. 1, 2, and 3, we have this dot. That's the y-intercept. What is the slope? What is the inclination of the line? -2/3. If the inclination is negative, the line is going to be, I don't know, right side up or right side down. Which one?
Right side down.
Right side down, right? So it's going to go 2 units down.
2 units right.
Exactly, and 3 to the right. 2 down, 1, 2, and 3 to the right. 1, 2, and 3. So we have this point. And then we can continue. 1 down, 2 down, I'm sorry, 2 down, and 3. And so forth. Or vice versa. Since I need to go in the other direction, I can go 2 and 3. And we have this line. Now the line, we have 2 choices. The line could be broken, or what we call a dashed line, or it could be a solid line. depending on the inequality symbol. In this case, it say strictly greater. So we are not including this line. So the line will be broken, line will be dashed. So we only use this for reference, and we kind of connect here. That doesn't look too linear, but you get the idea. Okay, so that's the line. What this line is doing, right? This line is dividing the plane, the paper, the board into two sections. The section that is on top and the section that is at the bottom. Where are the solutions? Well, then we do the testing. We pick a point, but we cannot pick 0, 3. We cannot pick this point. We need to pick any point on either area, whatever point you want to, right? So usually the hint is say to pick 0, 0 because it's easier, but any other point. So we can use 0, 0 for testing. To test. And what do we test? We don't test this. We test the original question. If 0y bigger than negative 2/3 times 0 plus 3, is 0 bigger than 3? Is 0 greater than 3? No. So that means the solution is not in this neighborhood. The solution has to be on top. So we graph, we shade the top region. Any point that we pick here would be an answer. Similarly, I can pick a point here, 3,3. And then I can find that that's true.
Sorry about that. Okay.
It's okay. Okay. Any?
One more like this.
Okay.
Okay. So let's try number 53. Then we can practice different ways of graphing the
The
line.
X and Y.
Mhm.
Yeah.
So number 53, we have the following. Negative 4x plus 3y less than or equal to 12. So that's the inequality. Of course, if it's an inequality, the whole idea is to graph the boundary line so we can split the plane in two sides. And then the solution will be one of the two, side A or side B. So we just have to see, we have to graph the boundary line. So first, graph boundary line. And of course, if it's what I like to call a hard inequality, less than or equal to, or greater than or equal to, will be a line, solid line. If it's a soft inequality, it will be dashed or dotted. Use dash or dotted. So then this one is going to be hard inequality, it will be a solid line. So what is the solid line? Negative 4x plus 3y equals 12. There are different ways of graphing the line. As the professor explained before, we can write it as y equals mx plus b. But this one, since it's written like this, this other technique that is the intercepts. This one will be easier to graph using intercepts. How do I find the x-intercept? Well, how do I find the intercept? We force the one variable to be 0, x equals 0, so we find the y-intercept. Y equals 0, we find the x-intercept, right? So we force one to be 0 and we solve for the other one. So this one is very easy, and I'm very sloppy graphing the line. So let's go ahead and do this mentally. What happens? How do I find the x-intercept? The x-intercept, we force y to be 0. When y equals 0, how much is x?
Y equals 0.
We have negative 4x equals 12. I don't know if you can see that because the resist in the way. So we divide by negative 4. 12 divided by negative 4, that would be negative 3, right? So we are down here, the x-intercept, we're going to hit the x-axis at negative 3. Negative 3, 0. How do I find the y-intercept? Where I'm going to hit the y-axis? Well, we force x to be 0. So now I have 3y equals 12 If we divide by 3, 12 divided by 3, 4, not 4, 4, 4, right? So y equals 4. So I hit the x-axis at -3, the y-axis at 4. This is going to be a solid line, so very straight line. I don't have my ruler, so it will be, oh God, it will be like a solid line like that. Yeah, give or take. Okay, so we split the plane in two sides, side A and side B. We need to shade half of that plane. So either the top A or B, we don't know. So now the second step is going to be, we use a test point, right? We use
Oh,
a
yes. The equation itself doesn't have to be, y equals mx b. I mean, that's all.
Doesn't have to.
Doesn't have to.
Doesn't have to. So we need to use a test point not on the line. As long as we are not in the line, just use you have infinite number of points. Of course, the easy one will be to use the origin as long as you're not on the line. So here for the test point, I'm going to use the origin 0, 0. And of course, we plot it in the original inequality. So inequality, so -4 times 0 plus x0 equals 0 plus 3 times, is that junk less than or equal to 12? We don't know. Of course, 0, 0 is easy because this is 0. Is 0 less than or equal to 12? Yes or no? Yes, it is, right? Of course, since it's and the 0, 0, of course, my origin is here. That means that the origin is part of the solution. That means that which one is the solution, part A or part B? B, because this is true, so the origin is part, so this is the solution. That's it. We're done. Okay. It's more, it takes longer to explain than what it is. Okay, so that's what it is.
And you notice that it doesn't have to be in this shape because we have different techniques.
Yeah.
In a slope intercept, this is the standard. So usually if you have it in the standard, the X, the Y, then the number, this technique is easy, like he did, cover here, cover there, you can kind of do it mentally. Then you have the other lines, the vertical line, the horizontal line. So those are.
Well, what we did, we just built the XY table.
Yeah.
But then what we did, we forced X to be 0 and Y to be 0. So we use
It's basically the same thing, but.
Exactly. That's what we did. Yeah. So when X equals 0, then for this was 4, we did so. Yeah, so then you just build a simple XY table or intentional XY table using the intercepts or Y equals mx plus b. Whatever rocks your boat to grab the line.
I like to make it difficult for me.
Yeah, no, it's not difficult.
No, because it's standard form, right? So if I want to put an x, y, z, I have to solve for y.
Yes, and then it's more work. But no, whatever rocks the boat for you, whatever is easier for you.
Whatever is easier, because for some students this is always easier.
Yeah.
Now this is usually easier if this number here is a whole number. Like if I don't end up to be 3 divided by 7, and then I don't want
to
to
do. It's a fraction.
And it's a fraction, and in that case, there is a fraction. Maybe the other method is easier. You have to find.
So whatever, as I said, whatever works for you, as long as you get it right.
Okay.
I know we're out of time, but there's just one question I remember on the test.
Yes.
Well, it was 2 because it was 1. I remember it was it was either negative or positive 4 with a radical x, either negative or positive 7. And that kind of got me confused.
Rationalize the denominator. Okay. Yes. Okay. Let's do that.
So the ones in the review, that would be problem number 73, 74, 75, or 76. So
yeah,
this one.
Yeah, like 73, you say, or square root of x minus 5 minus 7. Yeah. Number 73.
Sorry. Either just move it.
Okay. Number 73. 5 over the square root of x plus 6. So the idea behind this is that we want this to be a expression without the radical,
Yeah.
without the square root. We want it to be a rational number. That's what we call it, to rationalize, to make it irrational, meaning to eliminate somehow the square root, right? And in this case, since it's a binomial, two terms, the concept that we use is to multiply by the same quantity, but with the opposite sign. We want to use this technique of A minus B times A plus B. Because if we multiply the difference and the sum, we have the difference of two squares. We have the first minus the second, and we are canceling the inner and the outer terms. So that's what we're going to use. Since the question is a square root of x plus 6, the item that we should multiply will be the square root of x minus 6, exactly. We call those the conjugates, the opposite value. And then we FOIL. Either we FOIL completely, or we use the formula. Either case, right? We use the formula that will be a square root of x squared, which is an x only, and 6 times 6 is 36. So we end up with x minus 36. If we use the formula, this will be the square root of x twice a squared minus 6 times 6, 36. So this is x minus 36. Or if you want to distribute and FOIL completely, we still end up with the same. The square root of x and the square root of x, the square root of x squared, and so forth. Okay? The numerator is 5 times the square root of x minus 6. And in this case, there's nothing else we could do. We will just leave it like that. Because the whole point was to eliminate the square root. That's the whole idea.
Okay. Yeah.
Whatever they give you two pieces, you will multiply by the opposite sign. And the same was when we did the complex numbers. If we do 1 divided by, I don't know, 3 minus 5i, we multiply by 3 plus 5i top and bottom. The same concept.
I should have brought my other notebook. I had all mine. It's a mess. It's my Russian, and I also used it for class with the same notebook. And I had more problems on that. I was going over.
Okay.
One more like this.
I think it was. Let me see if I remember correctly. Because it was a radical. I remember I had the exponents.
Maybe it
It
was
was. I think it was something like this.
rationalizing by monomial, something that is not.
Yeah.
Oh,
Because I got it wrong simply because of a simple rule that had to do with the exponents, and I was mixed it up with it being like either minusing it or
Yeah, I can
cut
do
by
it.
half.
Let me just to set it up, not finishing, but just to set it up so it gets recorded. Number 76, I have 2 radical 3 minus radical 7 over 3 radical 3 plus radical 7. So the deal is to always multiply by the conjugate, right? That means that you multiply here by the conjugate, the dom, there will be 3 radical 3 minus radical 7. Right? So it's 3 radical 3 minus radical 7. So you multiply conjugates. So you can use difference square conjugates. So my denominator becomes a square minus b square, where the first term will be 3 radical 3, the second term will be radical 7. Right? It's always a square minus b square. We distribute the exponent, so that will be 3 squared is 9 times radical 3 squared, that's just simply 3. And 9 times 3, of course, 27. minus the square root of 7 squared. That will be 7, 27 minus 7, that will be 20. So we got rid of the square root from the denominator. So now my denominator is 20, and we have the mess on top. On top we can use these figures, and that's it. So we were able to get rid of the square root of an irrational number from the denominator. Why? We don't like to divide by an irrational number, especially in computing, it propagates a lot of errors, machine errors. So anyways, I just wanted to work only in the denominator. The numerator we can just FOIL, right? So the important thing, the multiply always by the conjugate, just the same term, but they mean the sign different. So we can use the difference square rule. A plus b, a minus b, first square minus the second square. Okay, and then what happens if we are doing the higher exponents? If I have to do the following, 3, the fifth root of x, right? Something like that?
Yeah.
Okay. Like how much I need to multiply so I get rid of that radical. Now, if we remember the rules of exponents, my goal will be to do the fifth root of x to the 5. If I get to match the exponent with the index, the answer will be x and the radical will be gone, right? So this is x to the 1. By how much I need to multiply x to the 1 so I get 5. 1 plus what gives me 5? 4. So I multiply by the fifth root of x to the 4 and I'm done. Okay? Because the goal is to match the index to the exponent, right?
Okay.
If it was the fifth root of x squared, by how much you multiply? The fifth root of x to the?
Sorry.
Oh, sorry. Huh?
No. Yeah. I was still processing that. And
Sorry. So it was like that. Remember, there is a 1 here. So I'm at 1. I need to get to 5. Why to 5? Oh, that's my index. Match the index to the exponent, so I get x.
Yeah. And so then
I'm at 1. I need to get to 5. So how many you need? 4 more.
Yeah.
If I'm at 2, I need to multiply x to the what? 3. That's it. That will be 3 here, 3 here. So the new numerator will be 3, fifth root of x cubed. That's it.
And what if you have x to the 7th? Now,
I mean, wouldn't it? So if that one's adding, wouldn't it subtracting? But that would be.
the index is telling you
Yeah.
how many you need in order to take it out of the radical. You need to make group of 5. So that's why when it was smaller, you kind of complete it. I have 2, I need 3 more. But now you have 7. I have 7 students, but they have to work in group of 5. That's what they say. Oh, in order for your class to run for next semester, you need to have 5 students in each class. Sure. And I have 7. So that means that I have to start calling. I had to start calling. You want to register for the class? I need more to make a group of 5. How many more do I need?
Like 2, difference of 2 now. Well,
It has to be matched in 5, but now I have more.
yeah, you have more.
So remember that this index is the same as divided by 5. So this numerator has to be a multiple of 5. So it could be 5 students, or I could have 10 students, or 15, 20, and so forth. So in this case, I need 3 more.
3 more.
3 more, right? 7 plus 3 more. If I can get 3 more, then it will be a perfect group of 5.
2 groups.
Exactly. You see it? So now we will need to multiply by x cubed. That way, in the denominator, we will have 7 and 3 is 10. And this is 10 divided by 5, 2. Voila. Now the radical is gone, and that's what we wanted. No more radical, the numerator is there, whatever it was. 3/5 root of x cubed. But we already complete the group of 5. So ideally, of course, if it's smaller, we try to match to that. But what if it's bigger? So we go to the next multiple. 5 times 1, 5 times 2, 5 times 3, until we get those divisible by 5.
Okay. Okay, I think we have time for one more. You have any one more, or you're done? Or you're fried? Huh?
I took the right road.
No, and if it's not enough with 1,
Huh?
now he has 2. Go. You rest, I rest, he does not rest.
On radicals.
Mhm. Yeah.
So hit me with one. Okay. Oh, maybe the number 77. I guess.
77.
Yeah.
Solving radicals?
It's like a yeah, but yeah. Mhm.
Okay. You do it,
Yeah. No, I'll do. You do science, but I would like to do something I did today because my students were so
Okay.
confused.
Okay,
So
so
even the way it gets recorded, so I'm using this. Let's see. If I have the square root of 5x minus 2 plus 3 equals
Mhm.
Okay. I was going to do it for a good number, so get some. What do we do? Sorry. We need to solve for x, right? It's inside the radical. So the drill is to leave the radical term by itself so we can then square. Okay? So we need to isolate all the junk that is surrounded by this, so then we can square. So this 3 is in my way. So what do we do? Minus 3. So now I have 5x minus 2 equals 7 minus 3 before. And now we square. So we square on the left, we square to the right. So I have 5x minus 2 equals 16. We add 2. 16 plus 2, that would be 18. We divide by 5, so x equals 18 over 5.
It's just doing what you did on that side to the other side, but
Hmm?
because you have to.
Yeah, so what we did was minus 3, minus 3. Yeah? What if I have the following? What if I have 5x minus 2 plus 2 equals negative 2?
So you subtract. Oh, it'll be 0. It'll be 0.
Oh, we
No,
should
no,
square? Therefore.
Yeah, so minus 2. Oh, negative 2. It'll be negative 4.
Mhm.
And
So I
then
have one.
and then you square 5x minus 2.
5x minus 2 equals negative 4.
Mhm.
And you square the
Yeah.
5x, so you
Yes.
cancel out the radical, and then it'll be negative 4 squared, which is
Yeah.
negative 16, and then
No,
Six-
no.
Negative 4
Oh,
times
16.
negative 4 is 16,
Yeah.
right?
Uh-huh.
And then, yeah.
And that's it, we're done?
oh what's it called? Simplify that.
We should always verify. We should always verify. Oh, let me opinion. Okay.
It's
I
ready
think
for
that
the
is my
next.
student.
We should always verify the work. However, be careful here. We should have stopped at here when I have the square root equals to a negative number, no solution. Stop there. Okay. If I plug in this number into the original equation, that would be false.
It's not gonna work.
If I had the square root equals to negative number, stop. Don't even spend your time continuing.
Oh,
You know, it's similar to the fractions, that this is a solution for this, but it might not be for the original exercise. In this case, it's gonna work, but if you check this number over here, plug it in, it's not gonna work because the square root is gonna be positive, but the other side
Right.
is minus.
That's the problem. The
Mhm.
square root cannot be a negative number. If you end up with this problem, stop, no solution. Okay?
But it's sort of like if I plug it in. it
Uh-huh.
will not work.
It will not work, exactly.
Mm. Okay.
You have to be careful with the even roots, the square roots. You
So
have to
let's-
be careful with the fractions.
So let's do it very quickly here, right? If I have 5 times 18 over 5 minus 2. 5 over 5 is 1. 18 minus 2 equals 16. The square root of 16 is 4. 4 plus 2 is 6, and 6 not equal to negative 2. Right? Right? Now,
And it looks the same.
Yeah.
Now, be careful because I always tell my students, just kill it right there. I'm going to erase, okay? Now, if you're working the problem, if you end up with the following, -3 times the square root of 5x minus 2 equals -12. Well, here I say, well, the square root equals the negative number, no solution. May I say the same argument here? No. It's equal to negative, but I have this annoying -3. So this one requires for us to divide by -3. Right? Now I have the square root of 5x minus 2 equals to a positive number. As soon as the square root equals to a positive, we may continue. The square root equals to a negative number, kill it. Okay? Now, if you have the following. Need to call it soon. I have a student. If I have,
That's for the next class or for this one?
I'll ask him later. If I have 5x minus 2 raised to the 1/2 equals to -4, what can I conclude?
Well, then wait. You would have to make it to radical, no?
Yeah.
And then, so it'll be 5, radical 5x minus 2, and then, I mean, it's still -4.
Mhm.
So, no,
No, because this is square root, right?
Yeah.
If it's raised to the 1/3,
then. Yeah, I mean, it'll be a
cube root.
cube root.
It would be cube root of 5x minus 2 equals -4.
Those are rule with that. I'm not sure it was the
Can
same.
we solve this one?
equation.
Yes or no?
Yeah.
We always have an issue when the index is even and the output is negative. That's a big no-no. If the index is
Yeah,
odd,
yeah,
who
that
cares? If in odd indexes, who cares? Anything goes.
Yeah.
Even indexes, we have to be careful. It cannot be
Yeah.
negative.
Yeah.
Okay? If it's 1/4, no solution. 1/6, no solution. 1/8, no solution. As long as it's -4.
That was-
Negative something, right?
Yeah.
Okay. Anyway, so I think we are, I have another gentleman, Mr. Daniel Chemi, who's your student? Daniel
I
Chemi?
think so.
11:05 or 10:33?
I don't know.
Hi, Daniel. Are you here for 11:05 or 10:33, sir? We are almost done with 10:33.
You have the same link, right?
Huh?
You have the same link?
No, it's a
No.
different link, so I need to leave. So this is why I said it. Daniel, you're here for 10:33. We are almost done. If you're here for 11:05, we respectfully ask you to leave and then join us in the 10:33. We need to
Maybe he
sign
got confused
out
with office
10:33 so we can join in for 11:05. Then we start at 6, right?
Mhm.
Okay, sir, sorry about that. I need to really leave now. I don't think he can hear me. Okay, good. So okay,
Okay.
then, so sorry. Need to leave, so-